the Royal Swedish Academy of Sciences has decided to award the 2023 Nobel Prize in Chemistry in equal shares to Moungi Bawendi, Massachusetts Institute of Technology, MIT, USA, Louise Brus, Columbia University, USA, and Alexey Ekimov, Nanocrystals Technology Incorporated, USA, for the discovery and synthesis of quantum dots.
The smallest quantum dots shine in blue, while the bigger ones shine in yellow and red. They only differ in size, nothing else. These achievements represent an important milestone in nanotechnology, and today there are numerous applications of quantum dots, ranging from QLED screens to imaging in biochemistry, medicine, and much more.
Different from molecules, if you imagine if you wanted to make...
So in this class of material, you have found a way of changing material. Now, the prediction that such an effect could occur in theory.
We see them in illumination sources where the LED light, the blue LED light, gets converted into a light that is perceived as pleasant by humans. It's also used widely in biomedical imaging, in this particular example, to visualize the vascular system of a tumor. But this is not where it ends. Research is still very intense, and there is applications expected or being heavily researched in producing photons for quantum communication, for flexible electronics, for sensors, for improving solar cells, making them better or cheaper.
Are you there, Professor Bawendi?
Yes, I am. I'm here.
Good morning.
Very surprised, sleepy, shocked, unexpected, and very honored. They're already widely used as color downshift services, which I'm already...
As a bulk material we have. It's the same atoms and the same constellation.
So let's move on now to more questions about the Chemistry Prize and the research involved. We deeply regret what happened, for sure. There was a press release sent out for us for still unknown reasons. We have been very active this morning to trying to find out what actually happened, but at this place we don't know that.
The size of quantum dots and some fluorescent...
Larger the energy of the electron. If you can...
So this is tiny particles that I show you. These are 30 million times bigger than they are in real life in nanoscience. Every university today has some kind of center around this. To illustrate this, here we have a bigger quantum dot that is about 3 nanometers, truly, and this is red. If I make it smaller, the same atoms, but just making the size of this ball smaller, I get to yellow, green, and then finally to blue. So, and this is only determined by size. So this is, you can think, what's the importance of this is tiny particles that I show you. These are 30 million times bigger than they are in real life. It's tiny, we can't see it. Can it be used for anything, or what's the point? And it has a lot of applications already today. Research around to find, you remove a tumor, is there any cancer cells? But the quantum particles, or quantum dots themselves, are used in displays today. TV, your cell phone, other types of displays. They give really good, strong, good colors to make the different pixels into colors. They're also used for example, converting LED light, which is really this sterile white light. You can convert it to a more warm, sunlight-like white light, and that's why they use it also in medicine. Quantum dots are really, they're really stable and they shine brightly, so you can use them to detect, for example, where is the tumor if you have a cancer, or if you just want to study organs, you can maybe see where, you color something in the body, what you can see. And even today, already today, I would say, it can sometimes be used to kind of guide surgeons how to remove a tumor. So it's really there. So there's a lot of already benefits to humankind.